Hello, everyone. My name is Marufa Bhuiyan. Today, I'll be speaking about Mars city-state design for 1 million population and integrated model-based approach towards Martian settlement. I like this banner, so I just put it out there as memory. And Mars logo is pretty cool. And here is our logos who are supporting us. Okay. So how Mars looks in the sky, in October sky, this is our month, shines really bright. I mean, we just put our telescope there and look at Mars and other planets. And every time I look through telescope, after that I have to meditate and understand that time passes at different rate for different people. Well, this is my equation, I'm just working on it. So today my contents are divided into like abstract. I'll just mention a few keywords. And then if I want to welcome Mars, I have two important questions to audience. And then I want to show our core team members research methodology and what are the strategies for the settlements on Mars. And I have some keywords for conclusion too. So 20 minutes for my talk. So abstract, maybe I'll just say the first few words from here, from the first sentence. So Mars used to be god of war in mythology, in ancient Roman civilization, but Mars in Bengali language means Mongol or peace, like blessings. So language is very important in how we define history and where we go from here to where. And other sentences, I'll just break it down in the later slides. So welcome to Mars. It looks so cool. Who doesn't want to go there? But I would like to go there someday. But then if we do settlements there, what do you want as like a kingdom? Do you want to be settled there as a king and queen as we did on Earth? Or what we want as a democratic society? I mean, we couldn't figure it out yet, but probably as time goes, we would know how we settle there. Here is our core team. We have all of our team members' bio in our website, so, but I just wanted to show our team members' pretty faces there and how we supported each other last few months. It was quite a journey. So maybe I should introduce myself a little bit who I am. So I'm born and raised in Bangladesh, and later, well, I studied biochemistry and molecular biology, my bachelor's and master's, and then I also grew up a little bit in Hawaii, studied electrical engineering for a while. But if I want to introduce myself, who I am here, it's my name, Marufa. Marufa is an Arabic word. Marufa means renowned or famous. And Bhumi means land, Bhuiyan means landlord. Well, I have nothing, but the Bhuiyan name traces in 14th century. 12 Bhuiyan ruled the Bengal and they fought with Mughal. And I have a middle name, Akhtar. Akhtar is Persian word, means star. But in Hawaiian word, Arcturus is the constellation. Hokulea means star of happiness or joy. But anyway, I mean, I think name is important, or probably it is not important, but it defines who we are and who you want to be. Some people changes their name. Well, that's not our topic today. So let's go next slide. So why Mars? I mean, since our childhood, we grew up with, wondering and imagination, like how Mars, I mean, and then recently I did this analog astronaut training in Utah, in Mars Desert Research Station. And it was quite a really great experience. So during that time, that was a medic mission. We were mainly focusing on medic health, but I was a crew astronomer and a greenhouse officer and resident philosopher. But on the last day of simulation, end of the day, I woke up with tremendous realization and understanding. It's like awakening, like how to cope when you are surrounded by idiots. That was really an important question for me. I saw this book in a local store in Utah. But this book, How to Live on Mars, really inspired me, and I just, when it was quite a journey, simulation. But then the question lies, like, are we living in a simulated world? So my research methodology, basically, it's a linear programming model, switch. Well, after I finish this database, it will be switch 3.0, or it might have a different name. But linear programming, when you put all the problems linearly, you can solve it easily. But life is not really linear, or problems are not linear as well. So we have to look at district level. And then you put locations to understand problems more precisely. So this is one way of our methodology. And then another way would be this feature scenario analysis, where you put your problems and solutions in a quadrant. Where do you see yourself? Is it here or there, minus, minus, or is it here? So we did this future cafe. I see myself in 2014 and literally here in Glass House, in a rocket ship 88, in my rocket 88 with my friends and family in an interstellar journey. Or I could be in my ancestral house in Nepal, sitting in a royal family, or Bangladesh, but I see myself here. So it's very easy. This quadrant way of doing it kind of simplifies your problems. But then, if you look back history, now we are in 2020. So time is the fourth dimension. We are in 2020. Before there was 0, and before there was now a Jewish calendar 5781, Nepali calendar 2077. So what is this happening with this time? So I think it takes time to realize that. And perspective is important. Like if you see this Cassiopeia constellation from here, it looks like M, here it looks like W. So a lot of things changes when you change our perspective. He's my favorite philosopher, Barton Russell, from British royal family. If he was alive today, I would ask him a few questions about the paradox. It's the Russell's paradox. Oh my God, what is this? I'm sorry about that. Anyway, I think best way would be scaling and scoping your consciousness wherever you are. You can look at yourself probably 3020, or I don't know, for an astronomer, time is just a dimension. They're like, so next slide here. Oh. So that was time, strategy 1. Strategy 2 would be settlements by locations, as you did on Earth, in some cases in the history, if you look back. So I will go here and some selected locations here, say, so maybe I'll just show it here how we do selection by location. So let's say this is an internal database, it's not public yet. We need to understand copyrights and future plans. So let's say here we are in Olympus City. How does Olympus City Olympus town at a glance? So 200,000 people, what do they need? They need living habitat, spaceport must, greenhouse for food, and then schools and universities are important too. But then from Olympus, if you want to go to Inca City, it looks different. Inca cities are on the north and south pole, in the equator where we have the ice. So here we have this governance. We will have this hierarchy or flat model we can decide as time goes. And then you go valleys, marinaries here. So this is changing here. Um, surveillance manuals. So I can play with more with this app, but just as an example, how we can settle by locations and how it will be different in different locations. This is settlements by locations. Oh, state of Jezero. I want to show this state of Jezero, how this looks. Yeah, like this picture and also. Anyway, so then, well, history is very important. History doesn't repeat, but it does rhyme sometimes. Like here you see 1659, Dutch astronomer created a map. And what happened after that? But a lot of things happen. And if you look back last 30 years, we have so many topics to be inspired, and from there we can go in many different directions if we want. It's really bothering this. So, okay, so habitat designs. First condition, there shouldn't be no sound pollution, like here we do on Earth. I think recently in this, Mars settlers have to find new way, creative way to do their construction work with bulldozers or different way to set up their settlement, but there we will put a placard there, like 60 decibel sound pollution limit, not 70, 60 or something like different. There will be limit of doing this and limit of doing that. And designs could be inspired by Mars Desert Research Station habitats. Well, I've been there and I like them very much. And then, but for space radiation, we have to design, add many different things. And then high seas habitats in Hawaii on the Big Island. All these we can find. So what did we have on Olympus Town? We had all these living habitats, spaceport, greenhouses, and governance is very important. And then third strategy can be by featured projects. Like we can start thinking from now, like what projects we have already on Mars. Like, because robots are already there. And if you're going there as a Homo sapiens, and we have to understand robots. So, but anyway, so here, Mars exploration and governance assessment tool. I will talk about this a little bit and all other projects. I like this interplanetary communication project too, but we don't have too much time to talk today, so maybe I'll just talk about one project here. So let's imagine what is mega tool. So let's imagine we have one team leader can manage 1,000 people through his project. So we need 1,000 team leaders. So you multiply 1,000 with 1,000 is 1 million people. And team leaders, they can be an artist, a philosopher, mathematician, construction worker, physicist, greenhouse officer, many different, we have all these positions available. But timekeeping on Mars is very interesting to me because I'm working on this timekeeping scenarios here. Like what will be how the Martian clock will work. And then scale of greenhouses, like how many we need and how many people we can feed. And then water, energy, and soil sustainability, which will be very different. I worked on this project at the University of Hawaii, from wastewater to methane gas production, from wastewater to biodiesel production, and then we do aeroponics on the top. And the methane is used for biodiesel. I thought that was a very interesting project. We can, excuse me, scale it in Mars. And then future plan. Well, future plans are important. I mean, here for Mars project, I imagine create an internal database and understand the copyright and classified documents versus declassified documents, and then and tracking of projects, tracking team members, and then human factors versus robot factors. And of course, inspiring the next generation of explorers. That should be necessary. And conclusion here, on Mars, even on Earth, I think GRAIN is an acronym for genetics, robotics, AI, and nanotechnologies. Should be strictly monitored and controlled. And then brain-to-brain interface would be important. I find it fascinating researching on brain. And then if we are going from Earth to Mars, we bring our charm and garbage, whatever we learn from through our life, from our family, genetics, and culture and society. So we have to be careful how we bring our charm and garbage in another planet. So religion and philosophy, aesthetics, and advanced mathematics, we need to quantify them and understand. And then characters and cultures in between Earth and Mars. And among us, there might be king, I don't know, like if you prefer as a president or king or queen. And then I was reading the sanity agreement. I thought it was interesting among nations because you don't want to fight over there with robots. And wisdom could be a tool for leadership decisions. And memories are important. Memories are precious. That's what makes us who we are on the present day, if we can have the luxury to reminiscent. So memories from Earth would be an interesting factor. It could be your Swatch watch, it could be your scarf. And we might build the Earth Museum on Mars. So finally, the main goal would be like interplanetary communication strategies, like we build a space hub there, and then life support would be crucial on Mars, of course, and safety first. I learned that during my training, analog astronaut training. And then we need to remember human wonder and imagination, as well humility would be necessary sometimes. And celebrating our success, but also inspiring the next generation of scientists and explorers. Well, this was my conclusion. And then here I took this slide from SpaceX website. I like Elon Musk's quote here. You want to discover great. So I think there are 2 minutes left. So within these 2 minutes, I will just finish my presentation. We have time 5 minutes for questions, but maybe I could show you how the governance would work. Governance is very necessary. So mega tool would be like here. This is still under construction. We're working on it. So let's imagine one team leader can manage this many people, and they will have under this many people. And this could be for one city or the whole planet. We can decide about that when it's necessary. Yeah, that's all I think here. Thank you. And now I will take some questions.
Marufa, can I?
Yes.
Sorry, I was just wondering, how could the average person get on board and become one of those 1 million initial colonists? Because I know there's a lot of people here that are like myself, really eager towards going towards Mars, that are not necessarily educated or specialist in certain subjects that might be handy, per se.
Pardon me, so what is your question?
Sorry, how could the everyman start to plan towards going to Mars?
So, so as I said, how could be every man? So if you define yourself who you are, and then understand, locate yourself. So for example, if you are here, let me go back to that here, governance. So if you like to be an ambassador, or if you want to be a greenhouse officer, you want to grow food, or you want to calculate your mathematics, or you want to fund 10 different. So if you can locate yourself who you are, probably you can understand where you want to go and when. I don't know if your question has any precise answer. How questions are very hard to answer. If you ask me what, like.
Okay, so say for example, I've got a background in networks and I'm really keen to make sure that we have a better version of the internet for Mars. How could I progress towards going to Mars with that skill set?
So internet is, are you a web developer, or are you a software engineer, or are you a data scientist? So there are many different experts.
Everything from back end to front end, but I'm talking at a base level infrastructure. I want to change things for Martians.
Yes, so you would like to work for robots or human? So maybe it's your priority what you want. I mean,
I'll work for anybody so long as I can get there.
So you would work for robots?
I'd work for robots. I'd clean the toilets for robots if it meant I had the opportunity to go to Mars.
Sure. Then we should educate our robots first on Mars. Then the robots facility should be organized, and then I think there should be plenty of. I mean, if you're especially a network engineer, I mean, I'm sure it's very interesting to you how you imagine yourself, and if you can locate yourself. But it's your preference who you want to work with. I wouldn't work with robot probably. I don't know.
Well, hello. I have a question.
Yes.
My name's Dara. I'm 13, and actually it's more of a suggestion than a question. To build dome cities on Mars, I think we should use origami robots.
How big are they? Like small size, like cube?
I don't know how big they are. I saw a TED talk on them.
Oh, okay.
They, instead of just doing one thing, they can actually change what they're building because they can change shape.
Oh, like origami art, like with.
Yeah.
Oh, yeah.
I think it's like a ton of different tiny robots connected that change shape.
Okay. I will look at it.
Yeah.
Thank you.
Because they're small, they're versatile.
Mm-hmm.
Hi, I have a question about, like, I saw the spectacular using of this, I think the 3D maps of Mars surface.
Mm-hmm.
How do you feel that maps can help you with this kind of developing a city on Mars?
Great question. Personally, I love maps. Any map, even like drawing. I like drawing in my hand, like star constellation mapping. That's my favorite, most favorite. But for Mars, like this here, I don't know if the video is on here. So this is the map, Mars map, right? And then you look at the history. Where, like, what do you like? Do you want to live on top of the mountain? Like, I lived in Himalaya for a few years, and I thought that it feels really great living on top of the mountain and look down. Or you prefer living in the delta side, in the ocean area? So I think mapping can help you to compare and contrast. When you have too many options and you want to compare between them and understand what is better for you. So mapping helps in that way. to narrow down your options, and so that you can choose one. Does that answer your question? I'm sorry, I don't know if it really answers your question, but
Yeah, I think that's great. Like, and also I have another one. Like, how much difference do you feel like finally, if we have a city on Mars, the difference between people on Mars and people on Earth, like they have totally different social systems, and maybe at last they have very much different moral rules. So, do you think that we can still consider them as a like single kind of people, or do you think they're another kind of people?
that's a good question. I mean, human side is all really matters. I think we need to remember it takes a lot of effort to be human. Homo sapiens, the wisest. I mean, it's not like being a monkey or a cockroach. It's like being human. So human issues and factors would be very crucial for the settlements on Mars, because there are already robots are there, and they can do all sorts of construction works if we can program them well. But for Mars settlement, we have to be very like thoughtful and creative how we do that. But because I still don't know the answer yet. Because it's nothing like war, God or God of war, nothing like that. Mythology is something and reality is different, and things have changed. So nothing really war or anything. I don't know. I mean, the way I imagine, but it could be different for others. But for me, human factors are necessary.
I have a question.
Mm-hmm.
What's your opinion on Asgardia? Are you familiar with their work?
Who?
Asgardia. So Asgardia is a space nation organization. They're trying to build the infrastructure culturally for humanity to unite on the ground in order to go forward in space, so that we don't take all of the baggage with us, you know, all the conflicts between religion and culture and nation. So far, it's in the 4th year. It's asgardia.space. Have you seen it?
How do you spell it? ES or
ASGAR
GAR
DIA
DIA?
DIA
Okay.
.space.
.space. Okay.
And it was founded by a Russian scientist named Igor Asher Bailey. And so far, it's gotten millions and millions of people around the world very interested in space colonization, from scientists to politicians to lay leaders.
Mm-hmm.
So I think something like this is really important, because if we go into space and we just take all of the problems with us, we're really not going to do better. But if we go there prepared to make a better civilization, then we'll go much further.
Yes, yes. That's the key words. I don't know if you will repeat the same. I mean, I'm still researching on this. Maybe time will say how things happen. But
Well, so for me,
pardon, no, you go ahead.
So I run an organization called Galaxis, and we're mostly on Facebook, and we work every day just trying to educate random people about the fact that we are in the space age. And one of the biggest hurdles we have is just getting people to prioritize it. Most people are more interested in Netflix than they are in space colonization. But with Asgardia, we've seen an amazing shift where people who would never have thought about space sciences are now excited about it. So it's a pretty amazing thing. If we have this mass excitement over space colonization, then the funding will follow. Then people will start pursuing courses, and we'll have more educated people.
Right, right. That is the way I think. I mean,
can I just respond to that?
Oh.
Hello?
Yes.
Hello, Jerry. Go ahead.
Hi. I'm the leader of a project running at the British Interplanetary Society, which is actually, I've called it the Space Project. That is, study project advancing colony engineering. Basically, what we have done is we've taken as a start the ideas of Gerard O'Neill from the 1970s, which resulted in things like this. And it's because the original plans for what they called Island 1 were deliberately restricted to the technology available at the time, i.e. in the 1970s. So I thought, well, we've had lots of improvements in materials, procedures, our computing capabilities are many, many orders of magnitude beyond what we had back then. So if we're going to build something out in space that back then was thought to need 2,000 construction workers, with robotic engineering, I doubt we'd need more than a couple of hundred. So the idea of the project was to revisit those plans and bring them up to date. And the result is a special issue of the Journal of the British Interplanetary Society, devoted entirely to the project, all kinds of papers about its structure and so forth.
How would I get a hold of that?
You can probably buy direct from the British Interplanetary Society website.
Great.
www.bis-space, that's space .com, and look for the publications.
Will do.
If anybody wants to contact me about it, jerry.stone2001, like on my poster, at gmail.com.
Definitely. Thank you so much.
But I mean, back in the 70s, the Island 1, which was the smallest structure that they were looking at, would hold 10,000 people. And to go back to Dora, the young girl who asked a question just a little while ago, these are free-floating structures. So not on the surface of the moon or on Mars, but floating out in space. And the simple reason that that was chosen was because you get the sun's energy continuously, which you can convert into electricity and have all the power you need, or you can focus the sun's heat and get 5,000 degrees, which would be enough for melting materials that you would mine from the moon, and so you can extract the aluminium, the iron, magnesium, oxygen, and everything else that you want. So there we go, out in space. But there's certainly no reason we can't go to Mars as well.
If you,
Cool.
who's that?
That's her in the background. She's very excited about that.
Where would you settle your location if you have a?
Now that's the other thing. The location that was chosen was the L5 Lagrange point. So if you picture the Earth there and the moon out there, then the first three Lagrange points are on a line that joins the Earth and the moon. But they're unstable. If you move away from that point, you will continue to move away. You would need thrusters for station keeping. But L4 and L5 are the same distance as the moon. One is 60 degrees in front of it and the other is 60 degrees behind it. So Earth, moon, and this point forms an equilateral triangle. And those are stable because of the gravitational pull of the Earth and the moon. If you start to move away from one of those points, you'll come back to it. But actually, you wouldn't be precisely at the point. You would be in a sort of halo orbit around the L5 point. And along the path of that orbit, there would be enough room for 20,000 of these habitats.
Thank you. Any more questions? Otherwise, I will just stop sharing and then join maybe. Thank you for joining. It was fun.
I just say thank you, and for what you were covering. Mars exploration and governance assessment. That's one of the things that is a major issue with regard to the space colonies. How will they be governed? What type of government will you have? And would at some point they might become completely independent politically of the Earth? And the same applies to a habitat on Mars once it grows to a suitable size.
Yeah, they have to be loyal to Earth.
Well, yeah, in the sense that they're not going to invade us. You know, headlines, oh, a real invasion from Mars. But no, but is there any reason why they shouldn't politically be independent, just like another nation on Earth? It'd be,
I think we're better off, actually, if they are.
Politics. So when I finished my analog astronaut training last day, everybody sharing their feelings. I just said one sentence. I said, I will divide my life into politics and equations. Which, I mean, not true. I mean, I'm not really fond of politics, but I love equations. So once you understand equations, politics very easy to understand. So on Mars, I mean, what would be the politics on Mars? What do you think? I mean, so far, I mean, I don't know. So Earth people, if they take their charm and garbage, so we have to make, we have to put our probably limit, upper limit and lower limit of doing things. Because robots are already there, they can crash us really quick. If there is no other questions, so I will just stop sharing my slide. Thank you for joining. It was very exciting.
Thank you so much for the chat.
Yeah, very thrilled experience. Yeah, thank you. See you another time. Yeah, thanks.
Thank you.
Thank you.
Thanks a lot. It was nice to listen to you.
Thank you.
Thank you, Matila.
Thanks, Sam.
I encourage everyone to check out Asgardia.
Yes, I wrote it down. Yeah. Good. So you're the founder of this Asgardia mentioned?
No, it's a Russian scientist named Igor Asher-Bailey.
Oh, sorry.
Actually, he's the he runs a magazine called Room.
Okay.
And he worked for Roscosmos as well. So he's already launched a satellite actually for Asgardia, and he's gotten quite a bit of interest from people. The biggest thing I've seen is that he's pulled people who would normally not care about space sciences into it, and they're starting to educate themselves, which is what we really need. We need more of the wider public to care. If we had the funding that sports has for space sciences, we'd all be living like Star Trek, you know. I think the average person doesn't care or even know that we're in the space age, unfortunately. It's one of our biggest hurdles, is just getting the information out there and getting the average person on the street to care about it and prioritize it.
Right.
When the British Interplanetary Society was founded back in 1933, we are the longest continuously running space organization in the world. One of our main efforts was to convince the general public and others that the idea of space travel was not a stupid idea. And sadly, we still need to do that.
I agree. Yeah. Unfortunately, the biggest thing I get is people saying, why do you want to go to space? We have enough problems on Earth, you know.
Right. Well, it's to solve some of those problems. Now, that was a thing that Gerard O'Neill specifically mentioned, that the idea of these space habitats is, first of all, you mine the material. Well, you don't mine the material from the moon. You scrape it off the surface. It's that easy to get. But you can manufacture the things. You can use the silicon to make the windows. You can make the structural elements and so forth. So you can build the thing out in space. And then what's the purpose of doing this? Well, one purpose would be to use a lot of that silicon to make solar panels. And you make very large scale solar power satellites, and if they're in, they'll be put into Earth orbit and beam the power by microwave down to rectenna on the Earth to feed into the national grid.
Mm-hmm.
The beam would fan out so that by the time it reached ground level, it would be 7 miles across. So the power level would be completely harmless. It would be less than the pressure of sunlight. So you won't have birds getting cooked as they fly through it or anything like that. And in fact, you could use the rest of the ground level for agricultural purposes in between all the dipoles. So the great advantage of solar power from space is that you put the things in the right orbit, and unlike on the ground where you have darkness for half the time, out there they're continuously in sunlight. And also it doesn't matter about cloud cover, the microwave beam will get right through that. So you've got continuous electricity, and they reckon that 15 years from the start of construction of a solar power satellite and building more and more and plug them into the grid, the entire project would break even. And after that, it goes into profit so fast and so high that you can start paying off the national debt. So that's one thing that space could do for us.
I think you really hit on something there. I think the biggest thing is part of that also goes into scarcity. Most of our problems on planet Earth are because of scarcity, resource scarcity, either real or perceived. But the moment we become a real, true spacefaring civilization, that disappears. We have pretty much unlimited resources. So most of our problems, I would argue with these people that most of our problems would be solved by going into space.
You're absolutely right. In fact, he listed, I can't remember them all offhand now, but he showed that 5 of the major problems facing us here on Earth at the moment could be solved by building these habitats. And for me, the major one is the resources that we can get from the moon. Now, one of the first big things about our project was that we added in asteroids, because in the 1970s, asteroid mining wasn't really regarded as a major thing, but now we know that, and of course you don't need necessarily to send a crew out there. Our robotics capabilities are incredible. So
I believe that's part of the Lifeboat's pitch. The Lifeboat Foundation is pitching this idea of robotic asteroid mining.
Yeah.
As an extension to their Voyager starbase they want to establish.
Right. So with most asteroids, you can use practically everything that there is there. And it's all easily accessible. So what it means is that we don't have to dig down or strip mine the Earth and basically, as people would say, make a mess of things down here.
True.
So we could help